Yeah, good enough. Cool. All right, we're going to get started. We got 3 talks. I'm Chris. I work at WePay. That's the next slide. I'm an engineer here. And I work on our data infrastructure team, which we kind of work on both the nearline real-time kind of feed and also batch processing. And so as part of our batch processing infrastructure, we sort of met and fell in love with Airflow about 6-7 months ago. I've been running it for a while. And so I'm going to be talking a bit today about what we do and how we do it. I've been here at WePay for about a year, and prior to that, I was at LinkedIn and PayPal. I don't know how many of you actually know about what WePay is or does, but it's essentially a payment processing company. The main claim to fame we have is we do platform payments. So most payments are like there's a buyer and a seller. With WePay, there's a third party, which is essentially a platform, which you think about like eBay, for example. There's a seller on eBay, a buyer on eBay, and then eBay itself. There's like this whole space growing up. I think we've got obviously Airbnb here, we've got Uber, and Instacart, all these different kinds of places. It's also very common to have this pattern in software as a service as well. And so we provide payment processing. So we have some unique requirements, which tend to bleed into what we demand from Airflow. We care a lot about security because we're in fintech. Also, in general, WePay, I think, tries to provide a lot of like risk and regulatory mitigation features that are specific to platforms and so on. So that's sort of who we are, in case you didn't know. 2 goals for the talk. The first one is I want to cover a little bit about how we use Airflow, some basic use cases, and then I want to spend the bulk of the talk on how we operate it. My goal with this meetup was to kind of like get a lot of small high density talks in. So we're going to do like a 15-minute whirlwind talk. And then I'll do 5 minutes of answers, and then we'll just sort of rinse and repeat and try and get as much exposure to how Airflow is run at different places as we can. So the usages that we have right now, these are sort of sorted in order of maturity at WePay. The most mature use case we have for Airflow is our ETL pipeline. So we have a bunch of tables that we suck out of MySQL and load into BigQuery. We run on Google Cloud. And so BigQuery is sort of analogous to Redshift on Amazon, Teradata, Vertica, and so on if you're in your own hosted environments. We run a fair amount of DAGs through the ETL pipeline, and I'll get into a little bit of detail about how we do that. We also have reporting uses where we either generate transformations to do internal reporting with Airflow, or we generate reports that we actually want to send to our partners, i.e. how much money they made, that kind of stuff. Monitoring is another use case we have where this is more of a, I guess, like a production debugging use case or a data quality use case. The data quality one is we want to make sure that the data in our database looks as it expected. Relational databases help with that a lot of the times if you use them properly. If you don't use them properly, you can end up with nulls where you don't expect and so on. Airflow has some nice check operators that we use to make sure that the data looks like how it's supposed to look. Machine learning is a big up-and-coming one for us. We obviously, as a payments company, have a risk area, and we try to prevent fraud on our platform. And so we are in the process of designing and migrating our batch machine learning and training pipeline into Airflow, which has been an interesting exercise that I can talk about later if you're interested in. And then lastly, I think this will probably be a future talk, but we're actually using Airflow kind of to replace cron. So these use cases aren't so much like workflow DAGs the way you would normally use Airflow. It's like a single task, but it's just generally like a script. And we run the cron stuff in production right now. And so we've had, we've scaled well past what cron can do for us. And so I think we're going to sort of converge on Airflow there as well. So that's the usage. I'll be focusing mostly on ETL, as I said. So this is our current stats for that's our environment, for our ETL pipeline. We have about 350 DAGs. We run about 7,000 DAG runs per day with about 20,000 task instances executing. A few things to call out. One is it sounds like a lot of DAGs, but they're actually very small, as you can see by the statistics, and they're mostly programmatically generated from just a few scripts. And the way this maps out is we basically do one or more DAGs per table that we load from MySQL into BigQuery. And so although it looks like a lot of DAGs, it's actually, they're very like micro DAGs, if you will. And that's worked really well for us. And I can talk about the trade-off. I think most folks tend to run fewer larger DAGs. We opted for the many smaller DAGs approach. There's some trade-offs there, especially in the scheduler loop and stuff. Wow, it's really a bummer I can't see my notes. I'm winging it. So in terms of the environments, the way the data flows for our ETL pipeline is we have our production environment where our primary databases are, all the web traffic goes there. We run 3 different environments, and these are actually separate Google Cloud projects on separate subnets and so on for Airflow and for our analytics processing pipeline. The first one is our ETL environment. And so what that does is essentially just suck the data from production into the ETL environment, maybe do a little bit of munging, and that environment is basically entirely locked down. No one can really get into it except for the infrastructure team. And then we have a developer and production environment as well. The developer analytics environment is where people write the DAGs that they want to use to do transformations on top of our data. So if you think about that usage list, the ETL bullet point happens here. And then most of the subsequent ones happen down here. So things like reporting, monitoring, usage, machine learning, and so on. And the flow, which I'll get into in a little more detail later, is essentially you write your DAG locally, you run it in the dev analytics environment, and then it gets promoted to production when you feel good about it. And production obviously has a higher SLA than dev. In terms of the deployment, as I mentioned, we run on Google Cloud. We have actually, I would say, relatively small footprint in terms of machine for Airflow. We run a single machine. We don't really have like a high availability failover for the machine itself because we kind of treat it as a batch system. And the caveat is like, it's batch, dude. You need to be able to withstand 15, 20, 30 minutes of downtime. And so we run on 32 cores. The primary use case for that is some of the ETL stuff. It involves parsing JSON, which gets a little slow at times. So we run a little bit higher cores than I think you would normally get by default on Google Cloud. In terms of the DB, it's just a very basic Cloud SQL 5.6 install. It's been working great for us. I don't think we've had a single issue with the DB other than just sort of the way Airflow treats the DB on occasion. But we snapshot that every few hours. So in the event of a true disaster, we can recover from that via last snapshot. We use Supervisor D to run Airflow, which keeps both the web server and scheduler up and running. We don't run, there's a switch in the scheduler called num runs, which will basically, the scheduler will kill itself after a period of time so that you can bounce it. And the idea, I think, is to refresh the state. We don't run with that. We did in a prior version, there were some bugs with zombies, which with Bulky, one of our committers, fixed. But we basically never got back to it. So we just use Supervisor D to pretty much keep the process up. And then last thing is Isinga for machine level monitoring. I am missing a slide here, which would probably be useful to a lot of people, which is how we monitor Airflow. So there's machine level stuff for Isinga, and then there's DAG level stuff where essentially we get reports based on SLA and based on failures and so on. But the actual monitoring of Airflow itself, we basically don't do right now, which is caveat emptor. This is not a recommended way to run Airflow, but it's what we do currently. I think at a minimum, knowing when your scheduler has halted is probably a useful thing. But we haven't had a whole lot of issues with it, so we've been lazy about it. I think a meta point there is, this is how we do things. This may not be the right way to do things in all cases. In terms of deployment, we run an internal fork of Airflow. And I use that word cautiously because we actually always run off the latest Apache release. But we run internally so that we can cherry pick stuff from master if we want to patch something that has not yet been released. We've had, when you run in production, at some point, you're going to run into a scenario where you need to fix something now. And so having our own internal release allows us to do that. The thing I want to emphasize, though, is that we never commit anything in here that is not in Apache master. So it's only going to be running ahead of the latest release, never diverging from it. I've been in scenarios on multiple projects before where that happens, and it's almost always really rough to get back on the main path. So we're pretty conscientious about that. This is mostly for posterity for people. I think there's been some questions on the mailing list, but this is the actual pip install that we run to install Airflow for ourselves. You can see the tag version internally that we have. We deployed directly off of GitHub, our little internal GitHub repo. We are not using like an internal pipe pioneer or anything, although that would probably be a better solution. In terms of configuring the scheduler, we run with a local executor, which this is a rather exciting area of discussion for Airflow, is local executor versus celery executor. As I mentioned, we're on a single machine. These are parallelism and concurrency and whatnot. I think one of the things you'll probably be able to deduce if you look at these configs plus the prior stats is that we've got a parallelism of 64, right? but we're running something like 20,000 task instances per day. The takeaway there is the task instances are generally very short-lived. We're kind of spoiled in that a lot of our work gets uploaded into the Google Cloud stuff, so things go pretty quickly. We do have some line running tasks, but the bulk of our loads are basically like 15-minute incremental loads from the DB that we stuff into BigQuery, and those happen, like we're talking seconds. And so we end up getting away with a pretty, I would say, low total parallelism if you compare to some other installs where they might be running many, many celery executors. In terms of logging, we stuff everything to var log airflow. I was talking with Sid about this earlier. His disks were running out due to the logs filling up. We had that same problem, so we turned on a remote logger as well. So all of our DAG logs, in addition to getting logged to the local machine, also get logged to Google Cloud Storage, which is analogous to S3. And we have a DAG which runs in every environment that periodically deletes any logs locally that are older than a few days. And so it sort of transparently fails over to, the web server transparently fails over to Google Cloud Storage logs when the files aren't local. And in that way, we basically don't run out of space. Because by default, if you run for a long period of time, your disks will fill with the log, and then you fail. We're playing around with ELK. We haven't spent a ton of time on this, but the idea there was to funnel the DAG logs as well as the scheduler logs and the web server logs all through ELK. But we haven't invested a ton of time in it yet. So I'd be interested to hear if anyone else is running it. These are our connections. It's pretty mundane. This is from the ELT environment. The dev and prod environments look differently because there's obviously different connections there. In this case, we have like our prod DB connections that we pull data from. We have our Google Cloud Platform connections, and we have our Airflow MySQL connection, so we can actually debug things. This is kind of meta, but you can add Airflow itself as a connection to Airflow, so you can query the DB through the data profiler to see like what's going on and why things broke. So as I mentioned, we care about security. It's sort of sad, but like a lot of people really don't, and so you kind of end up being like something nobody cares about and you care a lot about. But we're in an Active Directory internally. And so we're using the LDAP backend from Airflow. I actually just saw a PR come in today on this where someone's adding some new security stuff. But I'm happy to talk afterwards if anyone's curious about how we configure this and stuff. But what we do is essentially enable the LDAP backend. We set up 3 Active Directory groups that we bucket our users into. One is an Airflow user, one is an Airflow data profile user, and one is an Airflow admin, right? And so if you're, by default, if you're an Airflow user, you can log in, you can see the DAGs, you can actually do quite a bit, but you don't get data profile or admin access. If we add you to the other groups, then you can get those turned on by virtue of being a member of those groups. And that's worked pretty well for us. We had to do a little bit of hacking, and I think commit a few patches, but that's more or less work. I should say, if anyone else is interested in security, the other, I think, area that people are working on is the Kerberos side of things, which is very like Hadoopy. Now let's change gears and I'll talk about the DAG deployment. So most of what I've covered up to now has been Airflow itself and how we deploy it and run it. But there's also the aspect of how do you get the DAGs onto the environment and so on. And so we have a single mono repo right now for all of our DAGs. It seems to be sort of the standard for Airflow at this point, unless you do multiple Git checkouts from different repos into the DAGs directory. So anyway, we have one. If you notice there's a DAGs directory at the top. Inside that folder are 3 subfolders. One is ELT, one is prod, and one is dev. Any DAGs you commit into dev get shipped to the dev environment. Any DAGs you commit to prod get shipped to the prod environment, and so on. The development for a DAG starts locally. I think, again, because we get to cheat a little bit with Google Cloud and being entirely cloud hosted. They have a pretty cool local CLI that allows you to basically use OAuth to authenticate your laptop as yourself in Google Cloud. And then our Google Cloud connections actually pick that up and will execute as you in the Google Cloud environment, which basically means you can do real full development against all the data that you normally have access to, i.e. in the dev environment and so on, from your laptop. And so most people do the majority of their development just locally on their laptop, querying as themselves into the data sets that they need. And then when they feel a little bit happier, they ship it to dev. It runs for a few days. They feel good. They promote it to production. So this is an area where I think there's a lot of questions about how do you test DAGs and so on. So once you've done your development locally, you send a pull request, and we use TeamCity as our CI tool. And internally, you could think about, it's equivalent to Hudson if you're unfamiliar with TeamCity, or Jenkins, or any of these other ones, Circle CI, Travis CI, and so on. When a pull request gets submitted for the Airflow DAGs repo, we run a series of tests before we merge into master. The tests are more like smoke tests than actual DAG tests. And so they test a few things. We do flake eighth on all the DAGs. So that actually does a pretty good job of catching a fair amount of actual like syntactic errors and stuff, as well as some stylistic things. And we run code coverage and make sure things aren't going really bad in our Airflow DAGs repo. And then we run some validation on the DAGs themselves. And these aren't really like functionality checks for the DAGs. It's more like operability checks for the DAG. So we make sure the DAG has, the DAG can be imported by the scheduler. There's no import error when you import it, right? That's a big one. The second thing we validate is that the owner of the team, or the owner of the DAG, is like a known team. We have like a whitelist of people that we know can commit DAGs, and so you have to be on that list. So you basically have to declare this DAG is owned by the core payments team, or this DAG is owned by the risk team, or this DAG is owned by the API team. And that way, when things go wrong, we know who we can kind of like go bug, aside from the Git commit. And then the last one is the email. We want to make sure that there is an alert email so that when things go wrong, people know. And so we validate that as well. The sort of thing I want to get at that's not on the slide is that I think it's very common with Airflow, and it's sort of become the culture of it, but we think of DAGs very much as configuration as opposed to code. We think of operators as code and DAGs as basically config. And I think that works especially well when your DAGs are relatively simple like ours are structurally. But so we don't actually do a whole lot of testing with DAGs before we commit them. In some cases, we do data quality checks when they run, but that's always like validating that their output is as expected. In terms of deployment, this is like my least favorite part of our setup. Basically, I'm just in general not happy about the way we deploy the DAGs, but we use a cron that just kicks off every 2 minutes and refreshes the entire repo locally to the DAGs directory, which you can see there. That's the Airflow DAG for legacy reasons. So we just refresh, which means every pull request that gets merged in within 2 minutes shows up in the environment where it's supposed to be. And as a result of this, I think there's basically a competing philosophy where folks will use a deployment script like Chef or Puppet or something to basically deploy the DAGs. And as part of that, they will bounce the scheduler and web server. Because we're doing it the other way around, we're doing a pull base instead of a push base. We haven't really set up a way to bounce the scheduler and web server right now after a DAG has been deployed. We have some stuff we're experimenting with that's pretty cool, but we're not doing that right now. So right now it's just sort of like somebody manually goes in and pokes it and restarts it, which usually is like me or Moira or one of the other people on the DI team. And last thing I want to call out, very useful, disable your DAGs by default because someone will inevitably do something really horrible and then go home. In terms of the characteristics of our DAGs, I think this is one area I was talking about earlier with some people. I think Airflow has some very mature areas, and I think Airflow has some areas that are very much experimental. And so I can talk at length about the features that we do and don't use. But in terms of the DAG that we build themselves, we try to keep almost all the work off of the Airflow machine itself. So you'll see things like Bash operator and Python operator, and isn't it amazing? You can write all this Python code, and then you like take all the cores of the scheduler down, and it just nukes the entire executor. In our case, we do most of this stuff in BigQuery, which means that the task is pretty much just sitting there pulling for the status of the BigQuery stuff. As I mentioned, I think we're very lucky right now. A lot of our learnings are still early days because we have very homogeneous set of use cases. It's basically majority ETL right now. I think as we add things like machine learning and monitoring and reporting more and more of those, we'll get a lot more heterogeneous setup and probably suffer a little bit. But in the meantime, we're pretty lucky there. Last thing is really important, if you can at all possible, make your DAGs idempotent so that you can rerun them at any time. All of our DAGs right now are idempotent, so we can like literally go and clear the entire DB, and everything will work as expected. It will just refresh for several days. And this is more of a philosophical thing, but we don't use backflow here at all. So we use only start date. as a way to backfill these tables. So if you imagine you've got a table that's been around for 4 years, you need to backfill all that data, right? If you're doing, say, daily incremental loads, then every day you load that day. You need to run the past 4 years worth of days when you start initially. One way is to set a start date of now and run a backfill for the prior days. The other way is to actually set the start date to be 4 years ago, and then the scheduler just catches right back up, right? So we do that latter approach. When I was setting this up, basically backfill was super unstable and it just did not work. And so we went with that route, and that ended up working pretty well for not just getting around the backfill issues, which I think are starting to get cleaned up, but also because, as I mentioned, we're doing table level DAGs, it gives us the ability to toggle on and off specific ETLs on specific tables without impacting the entire DAG as a whole. We can also clear state on a per table basis versus having to kind of like slice a DAG both across time and some subset of tasks. So it's worked pretty well for us. It does put some scheduler on, it does put some stress on the scheduler because it's not really, Airflow wasn't really, I think, expecting to run like, 350 plus DAGs when the original scheduler loop was written, although it's being improved pretty dramatically. So for reference, our scheduler loop runs in about 20 seconds now, 15 to 20 seconds, which means if a task finishes, it'll take within 20 seconds before the next subsequent one gets kicked off. That's it. So I made it. So I have the obligatory we are hiring if the stuff interests you or payments interest you, come see me or anyone who works at WePay, but I'm happy to answer questions. I'm 2 minutes over on time, actually. Max, yeah. Elastic, so ELK is basically a tech stack. It's Elasticsearch, Logstash, and Kibana. It's these three tools that I think Elasticsearch kind of took over. Oh yeah, sorry, didn't use that. The question was, what's ELK? So it's basically three pieces of technology you can glue together to shift logs out of a file and into basically a search index. It's like a poor man's Splunk kind of a thing. I think I saw someone with a Splunk shirt here actually. But it's sort of like one of the new cool things. So yeah. Throw it at him, Francis.
Hello. So I saw the Docker files folder. Do you guys everything containerized or?
Oh man.
Sorry,
man.
It was like a bait, I had to take it.
No, that's an excellent question. There's two parts. One is, do we run Airflow itself in a container, like the scheduler and the web server? And the second part of that question is, do we run the DAGs within a container, right? The answer to both right now is basically no. The Docker file that you saw is for running the tests in the Team City CI build environment. We spin up a Docker environment there, pip install a bunch of stuff and run the tests. I will say our plan is to run both in Docker. So there's a guy who I said I was going to call out right there, Amit. He currently is running it in our integration environment with Airflow inside Docker file. You can probably, or Docker container. He can probably tell you much more about it than I can. He also has some cool stuff, I think, like restarting the scheduler lazily so that you wait until everything dies to bounce DAGs. But the short answer is no. The dream is obviously that. The bigger dream, I think, is something that's been discussed in the open on the mailing list is how we do distributed DAG execution. Right now, it's really not contained at all. And from an operational perspective, it can be really rough because, you have folks coming to you from your risk team who have like all these amazing SciPy, NLTK, Fortran, like Java, Stanford, R, right? It's just like a nightmare as an operator. You're like, oh my God, how many of these do I have to install? Especially with Python where it's like half pip, half yum installing these packages. So Docker will fix all of that. I think we're still in the early days of discussing how to do that. Maybe Max can give some color on that. But.
So I was planning to talk a little bit about this stuff that we're working on. That's one of these things at Airbnb that's like at the forefront of what we care about at this point in time. We want to, do a design proposal, send it to the community, and get some feedback as to how it should be done. Obviously, we're not just solving this problem for ourselves; we're solving it for others, and we'd like to get help for providing the solution that works for everyone. There's been some early talks, so we're thinking about adding a kind of a container ID to base operator, so you could reference an operator have an interface that knows how to fetch a container. It might be Docker, it could be other things. It seems like Docker will be the first implementation of that interface. And then C group type of base operator, you could say how much memory you want to allocate, how many CPUs, and then this somehow on the worker would get instantiated at the time where we kick up the task. If you set that up, it would fetch a container, get the DAG info in there somehow, and run your task instance within container properly with the right C group or like resource allocation. That is super important to us because we're killing another system called Kronos that we used to own and that we kind of given away. And we haven't been able to migrate some of the tasks that were in Kronos because we need containment. We need containment pretty bad. There's a lot of people running, like unfortunately R is big in our environment. So, so that makes containment really important.
I'm going to cut the questions there because we do have 2 other talks. I'm happy to answer more. I'm planning on being here for a long time. So, okay. This is Sid too. There's a switch. So this is Sid. He's also a committer for Airflow. Also ex-LinkedIn/Microsoft survivor like myself. He's currently at Agari, which is a spam detection startup for mostly search. I want to steal your whole talk.
All right. Thank you very much. Okay, so I've been using Airflow for about a year. I first discovered it when I saw Max's talk at Hadoop Summit last June. And at that time, we needed something better than cron. A little bit about what Agari does. We make email safe again. And the reality is that actually it's not ever been safe. SMTP has been around since 1970, and just the security protocols that have developed are more recent than that. And it's very easy, I think, for some of us to be taken in by links that seem like they're from legitimate email sources, and then we get phished. So our first product, which was maybe around 5 years ago, was just about like protecting consumers. So I found out about Agari because the companies I previously worked at, LinkedIn, eBay, PayPal, Netflix, they actually all use this to protect their consumers from being phished by people pretending to be them. And typically like 80% of the inbox providers like Gmail, Office 365, Yahoo will authenticate email that comes in with the right stuff and drop it before it even gets to your mailbox. You don't even know that Agari is sort of protecting you. But more recently, we've started entering the enterprise space, mostly because companies like LinkedIn/Microsoft were hacked through an email route, and 17 million passwords were put on the dark web for people to take. So we are basically taking our product and building something that's for enterprises. So imagine that we have these customers, enterprise customers. They send us their email headers, and we analyze those headers, and we have to make a decision whether it's a phish or not a phish. So that's a little different from spam, right? Spam is stuff like you don't want it, you don't care about. Phish is something more insidious. It's sort of like pretending to be from your bank usually. And one of the links out of 50 links is actually a bad link. All the other links are actually good on the page. So we try to solve this using data pipelines and machine learning. And our current product, our existing product is just showing the results of potentially bad emails to our enterprise customers. And our future email will actually try to eliminate the email before it lands in an enterprise inbox. That, in a very short sort of blaze is what Agari does. So how does Apache Airflow fit into this? So we use it for 2 classes of orchestration. So one is to build trust models, essentially machine learning and model building workflows. And I'm not really going to talk too much about that in this talk because I thought I only had 20 minutes. I probably only have 10. But just to give you a sense of what that does is every day we build models. and we deploy these models to scorers that are running in the cloud, and those scorers are getting email, like an email flow in, and it's scoring the email as trusted, not trusted, trusted, not trusted. And we use Airflow to build those models and deploy them in a rolling fashion via what's called an autoscaling group to our scorers in the cloud. But I won't say too much about that in this talk. The other thing we have is our scoring pipeline. In December, we went GA with our batch pipeline, and our batch pipeline uses Airflow. Since December, I've been working on our real-time pipeline. It's using Airflow for this other source of stuff, which I'll call operational automation. Typical like enhancements to cron. One example is that we use Kinesis and autoscale groups in the cloud. And we use Airflow to detect when we're at a limit of the provision for Kinesis or Dynamo or autoscaling. And we preemptively autoscale all three of those resources to avoid a bottleneck that would cause us to miss our SLAs on real time. And when we see things have settled in, we'll scale down to cut costs. And these are things that fall under Airflow. We're using Airflow for those sorts of use cases. So like I mentioned, today we're mostly going to talk about what's called message scoring and our batch pipeline architecture. So imagine that we have these different customers, right? Like I can't say who they are, but let's say enterprise A, B, and C. They're continuously getting email. And every 15 minutes, we load their files into an S3 bucket. And then Airflow on an hourly boundary will kick off a Spark job. And that Spark job is essentially reading this data. It's generating scores, saying whether an email is trusted or not trusted, and generating all sorts of statistics, like buckets. Then the job will write this data to another S3 bucket. And we have this S3 bucket configured to generate event notifications. So if you've used, just to get a sense, how many people here use AWS? And how many of you, keep your hand up if you know about this feature, SNS, SQS, notification from objects. Excellent. Right, so as objects land, notifications are pushed to SNS, and SNS will then push out to SQS that a new object has landed in S3. And then we have what's called autoscaling. And let me ask again, how many of you use autoscaling for your instances? Excellent. So there's a feature in autoscaling which allows us to scale up instances based on the number of messages in an SQS queue. So the idea here is we don't pay for any EC2 instances when there isn't a job going on. So every hour, the Spark job is kicked off. It finishes in 10 minutes. It generates a whole bunch of output data. That data is pushed into an SQS message queue. And when it lands there, an autoscaler will start up a bunch of EC2 instances. And each of those instances will start importing this data into our database. And when it's done, the autoscale group is spin to 0, and we don't pay for it. So it's really a cost saving. And then finally, our customers will check out our website and look at the emails that we've marked as suspicious. And right now we're in a prototype phase for our product. So this is how we're getting feedback for our models, our trust models. And eventually when we get enough feedback and we feel comfortable, we'll push like our enforcement product out that'll actually kill email. That's bad. So Airflow manages this entire process. And the next thing will be for me to tell you a little bit about how that's done. So this is our DAG, and I'm going to actually walk through it rather than it being an eye chart for you. So that DAG, I will say, is really that whole orange thing over here that is being managed. So the first thing we do is at the top of every hour, we actually wait. We do nothing. And this is because S3 is, how many of you use S3? And how many of you are aware of its eventual consistency issues? Yeah. So typically, so S3 has eventual consistency on list operations. So what our Spark job does is that it will get a list of all the objects in the bucket, and it will distribute that list out to its workers to work on it. And any object that landed within a few seconds may not show up in the list operation. So you will miss data if you don't wait a certain amount of time. You can get around this if you use EMR and you use EMR FS, which has a feature for strong consistency. But if you're not aware of this, there's a good chance that you're actually missing data, especially if you have data dropped on S3 and then you immediately on that hour start reading data out. And we ran into this problem in an interesting way. I'll kind of get to it a little later, but we were actually taking data that was ready to be ingested and moving it into like a working directory, and then moving it from the working directory to an archive directory. And and we would do a list operation in between. And what we'd sometimes get is data lost or duplicate data, because on the way out, if you do a list again on that middle bucket path, you'll find data that should have been moved out, and it's still showing up in a list operation. And we discovered it that way. So what we do is we put a little wait of 5 minutes. It could be 3, but 5 minutes seems to be good enough before we even start our job. Then we decide whether, we run this every hour, but 1 hour of the day in this old DAG, we also did a model build run. So we ran a model we were basically killing 2 birds with 1 stone. We would also do a model building run. And if it were that hour of the day, we would do the stuff on the left, which actually generated 3 different types of model builds and then validated the data at the end. And we're using a branch condition at the top to decide which way to go. Otherwise, we're going to, if you use a branch operator, how many of you have like played with a Python branch operator here? So a few of you, so you'll be aware that there's sometimes like you need to put a dummy task. Otherwise, it always runs something, maybe it's a little unexpected. And Matt actually helped me with that a few months ago. So there's a dummy operator there to avoid executing what's called a join operator. So imagine this is a little bit like a diamond. I don't think this, all right, here's a laser pointer. So that's the top of the diamond. You can go left or you can go right. And then you join back at a join operator, which is right here. So you always need a left leg and a right leg for a 2-way branch. Of course, if you have n-way branch, you'll need multiple legs. And then this is what this join operator is implemented using like a trigger rule. And the trigger rule for us is 1 success. So either this has to be a success or that has to be a success for this to be triggered. And this operator is also an external task sensor. So how many of you sort of may be familiar with external task sensors? Of course, Max is. Not a good sign, right? Yeah, so external task sensor is a way for one DAG to depend on one DAG run to depend on the completion of a previous or external DAG run. So let's say you had there's a common question on the emails, which is like, I have a daily DAG running and I have an hourly DAG running or vice versa. And I don't want one to start before the other one has completed and within its time period. And in our case, we use this as a self-referring sensor. So it depends on the previous hour of the same DAG. The reason is that we don't want our DAGs to run out of order. And we don't want them to run out of order because down here, we actually send alerts to our customers. And we don't want to alert them about an email that came like 2 minutes ago and then send them one about an email that came 10 minutes ago. We want them to get alerts in order. So we kind of use this external task sensor to depend on the previous DAG run of the same DAG. So that's what that is. And of course, there'll be time for questions. Then we do a bunch of pre-clean or prep stuff that happens in parallel before we actually start our Spark job. And then our Spark job is actually executed. So we use, in some parts of our DAGs, we use EMR. And in some parts of our DAG, we use standalone Spark jobs, Spark clusters. And of course, for this use case, it's a standalone, like constant Spark cluster. And we execute it using SSH. We're just making remote calls to an EC2 hosted Spark cluster. And when it's done, we want to make sure it's working. So this step right here checks that data is landing in our DB. If it's not, there's some bug along the way. And then once it detects that at least one record has been written to the DB successfully, it then starts waiting for the SQS queue to drain to 0. And when the SQS queue has drained to 0, we're done. We know that all the work is done. And finally, at which point, if you guys remember, go back a little bit. This is sort of our architecture. This SQSQ here, when it's drained, it means that essentially we actually check what's called the SQS has a visible and invisible or in-flight messages. We make sure there are no in-flight messages left, which means the last message has been committed. And then we will move to the last step, which is right here. At the last point of our DAG, we start computing discrepancies in the whole pipeline. We basically check every stage of the pipeline to see the counts of data that have arrived. And then we update some internal monitoring tables, which I'll show you a little bit about. We send in an email report, and we also raise SLAs via our different connections. So what do we mean by SLAs, right? So if you work in data pipelines, which I think all of us have, for us, these are the four most important characteristics of a data pipeline. One is that it should be correct. So we should have no data lost, no data duplicated, and there's no data modified in a way we didn't expect. We're doing predictive data pipelines, which means that we're actually scoring data. That means that the data distribution has to be something we expect. So we actually use Airflow to run a check on our data distributions to make sure that our scoring distributions don't change too much. And if it does, we need to find out why. Timeliness. We are alerting our customers about something bad. We do it every hour, so it has to be on the hour or very close to being on the hour. Operability. So this is where Airflow really helps. Monitoring, alerting of these SLAs. And then the cost is essentially the auto scaling that you saw earlier. We auto scale to reduce our cost as much as possible. So what I'm going to focus on are kind of these two things, these two SLAs. All right, so when an hourly job ends, when it stops, an email is sent to the engineering team. And on the left side are just our different customers. This is our stage data. So our different customers. And right here, we have discrepancy numbers. They're 0, right? Obviously, that's a good thing, right? So initially, our first pass was, we're going to get these emails. People will look at them and say, is everything in this column 0? Yes, great. There are no bugs in our pipeline. But people are always checking in code. And every time they check in code, something will break. And as you know, if you remember from our data pipeline, we have multiple stages. So this is the stage of data arriving from our customers. This is basically collector messages. Then the Spark job runs and generates output, and that's the output of the Spark job. And finally, it gets imported into our database, and that's our database message count. We compute all of these at the end of the run to detect late arriving data, right? And this is sort of how we detected the S3, the eventual consistency problem. You have to compute these at the end of your run. And then we make sure that this number acts as 0. If you notice, these don't act as 0. And we actually have a skip column. And this skip column are acceptable skips based on certain logic in our Spark job. But when before November, these numbers were in the 20s or 30s sometimes. But we basically found and fixed all bugs in our Spark job to bring them down to 0. And we were able to do that. And now anytime anyone pushes code, the next hourly run will typically find a bug. And then we say, hey, your code you just pushed, it has a bug. And you can see it right here in this email. But beyond email, we also leverage the data profiling aspect of Airflow. We can basically generate, so I mentioned the last stage of our pipeline, writes data, like right here, this stage right here, we compute discrepancies and we actually update monitoring graphs and database tables so that when our monitoring graphs can show when we have a problem. And this is a customer that for some reason is dropping sometimes almost 60% of its data on every hourly run. Then we we look at the code and we find some edge case in Spark that we weren't handling. And then we fix it and we get it down to 0. And that's for every customer that comes in, there's a new edge case we find. And then the other thing that's very cool about Airflow is that we use Slack ops. So these two alerts that we're getting up here, and I'm actually on call and I turn my phone off because I'm getting paid. But, basically right here, it means that we're missing SLA. For some reason, we're not making every hour, and it tells you which hour it's missing. So this hour is delayed, that hour is delayed. And the way we do this is you can specify SLAs in your tasks. And in the last release, the 1.7 release, we actually implemented callbacks. And this callback actually will do two things. One is it will put an entry into Slack, and it will also send us like PagerDuty VictorOps alerts. And the other thing that's sort of cool is I mentioned the discrepancies. So if you'll get this if we get anything over like 1%, and then on your phone you click on it and you see the graph of discrepancies like the monitoring graph I showed earlier. Like if you click on that, you will actually see this graph on Airflow. And then I think, right, and this is, it also, all of these alerts get sent to VictorOps and we page whoever's on call. Now operations, so we run in AWS. We run in US West 2 with currently 2 AZs, 2 availability zones. We have 3 environments. So our dev environment, and each environment has its own account. So that gives us like isolation between the environments. The developer environment is sort of a playground. We don't even run Airflow in this environment. It's just for users to generate to try out new services. And then we have a pre-production environment, that's stage. So stage actually is all of our production data plus some stage data. And the reason we do this is that we can detect scalability problems before we go to prod. Also, whenever we bake anything like code changes, we bake them in the stage environment, or also system upgrades. And then we, of course, have a prod environment. So Chris mentioned security. Security is important to us. We're a security company. So first of all, each of our environments has its own account. We use security groups and VPCs, and we lock every EC2 instance down. You basically can, it cuts off pretty much every protocol and port, except for 80, essentially, on HTTPS into the box. And it only allows SSH from other, it only allows traffic from anything else in the VPC or in a peering VPC. So you can't access it from outside the VPC. And the Bastion host is, of course, the one exception to this rule. The Bastion host allows like SSH to that box. And then we use SSH like port forwarding to get from that box to the other boxes. Why do I mention this? So the way we run Airflow is that, so that's like, that's a developer right here. And he uses SSH to get to the Bastion host, where we're running Apache as like a reverse proxy. And we terminate SSH, we terminate SSL there, or SSH there. And we then like challenge him or her with a login. And if he or she logs in, then they get access to the workflow box where we're running the web server. This is how we lock down access to Airflow. Once you get here, then you can sort of do anything you want, as most of you know. And then we also run a scheduler here on this box. And we're running local executor just like Chris. And we are accessing our metadata DB on a Postgres instance running on EC2. For fault tolerance, instead of, what were you using, Chris? Yeah, supervisor D. So you're using supervisor D to keep your instances up, and I think a lot of people do that. To keep your process running, we use Monit. So Monit keeps all of these things running, like the web server, the scheduler, the Apache web server, of course. And then for additional sort of scalability in prod, we run 2 machines with 2 schedulers running local executor. So this actually doubles our like throughput capability, and it actually works for us. I don't think that was the intended purpose, but it actually works. And that's one way to scale if you don't want to use Celery. Finally, repos. So this is the main repo, and we have 2 forks. One is, say, for example, my fork, and one is Agari's fork. And currently in prod, so we deploy everything from the Agari Airflow fork. So currently, in prod, we're running 1.6.2. Stage is closer to what's in master. But in prod, we pin this to a version on master. On the main repo. And then anytime like and of course we, individual developers of the company keep their forks in sync. We create a PR like PR 191. We'll send a PR request to the main one, but at the same time, we will cherry pick it and run it in stage and prod. Often it's running there before it's actually merged. So we run it for a few days, and then currently that's how like we deploy. Our fork has everything from a release version and everything we cherry pick in. That's very similar to essentially what is happening at WePay. And then we deploy that to stage and prod immediately. This is our current team. I'm not sure how many are here because I think there were some production issues going on. But finally, questions. All right, any questions or should we go to the next one? What do you guys? All right. Who's the next? All right.
I think actually you okay. You take your time. Do what you want to do. This was not a presentation. I know. I was just saying. Let me do a brief intro. You got it? Yeah, there's a Oh, yeah, I did. All right, so last talk for tonight before we open it up for, I guess, discussion. And I think Max wanted to do some talk on roadmap. I think probably Max, Sid, and I want to talk about roadmap a bit. This is Praveen. He's from Yahoo. And are you part of the Flurry acquisition, or you work with
No,
Flurry?
I work with the Flurry team right now.
Okay, so he works with the Flurry team. I think you guys have some interesting Druid, Airflow, analytics stuff. So yeah, welcome.
Thanks.
Okay.
Hey guys, my name is Praveen. I work with the Flurry team as a backend engineer today. So I just wanted to spend, I know we're running low on time, but I just want to spend a little bit of my presentation on why we chose Airflow and what Yahoo has been using primarily these days, and why we were looking for new solutions for our use case. Cool. So for those who don't know what Flurry is basically an analytics SDK, and we basically help developers to analyze consumer data. We give you guys an SDK that for you to embed into your apps and understand how users use your apps, and give you a nice dashboard for you to look at and get a sense of where users are spending most of the time on, and how users use your app specifically for you to help improve later on. And some metrics here for us in terms of how much data we actually process. 10 million sessions every day, and Snapchat is one of our major customers that we actually use that uses Flurry today, and we have a total of 800,000 apps going on and 250,000 app developers using Flurry today. So let's dive in right away. So our solution, our problem statement here first was we were looking for a workflow to help us move towards Druid. And for those who don't know what Druid is a columnar data store that we primarily use for providing real-time analytics for our customers. So recently, a few months back, Flurry launched real-time analytics where you can actually see your sessions and active users as users download the app and start using it really, really quickly. And we moved towards a new, I guess, an Apache project called Druid, and we have one of our co-founders working with us on it. And our goal was to basically get data from HBase, which Flurry uses primarily, is a source of truth for us, and ingest some of the data there into Druid. And this is where we're actually looking for some cool workflows, I guess workflows, basically, to help us do that. And I want to talk, mostly spending my time on how bad Oozie is in terms of, like, we evaluated Oozie and Airflow when we were looking for it, and we spent a few days on it and figuring out what were the major pain points in terms of if you chose Oozie versus Airflow, and I'm going to spend my time on that one today. I know the previous speakers spoke quite a bit about Airflow itself, and this is going to be like I guess the key points that got us to Airflow, basically. Cool. So let's start with the 5 main pinpoints other than the UI. I've not even listed UI here, but the 5 major things about Oozie that bothered us really heavily in our minds. So let's start with a strict directory structure. Oh, let me list the 5 here. You can see there's a really strict directory structure that Oozie wants you to use. You're basically forced your hand on. The second one is Oozie doesn't support automatic reprocessing, data handoffs, config-based, and there's something about waiting states in Oozie that you need to know about. So first, let's talk about the directory structure. Even before we got into deciding on what to use, we knew exactly how we wanted the directory structure. The data should actually be in HDFS. We primarily use HDFS before ingesting data into Druid, and we exactly knew what we wanted in terms of helping debugging us, for future purposes. And the directory structure is basically as follows. So we have a base directory in terms of whatever table that we actually want to store inside Druid. The second one is what day does the data belong to? So for today, we want to know that it's today's data. And so we have the date directory there, and then we have the versioning, which is maintained with a Unix timestamp in terms of telling us what versions actually being processed, in terms of what the latest versions actually are for that day. And so this is the basic directory structure that we absolutely really wanted, because this helps us in debugging in terms of, let's say you ask a question to somebody, say, hey, how many versions do you have for this day? What's the latest version for this day? And so simple for us to actually go in to HDFS and say, okay, hey, there we go. So you just go into the date directory, say, okay, what's processed today? So today's the 13th. You go into the 13th of May. What's June? Okay, 13th of June. And then you go there, you find out what the latest version is, and then bam, you know what the latest version is that's actually being processed. So how old the data is and all that stuff. How maybe an hour old, maybe a few minutes old. This helps us manage all that stuff really quickly. And for debugging purposes later on, this is very straightforward. And we found out that this directory structure was really hard for Oozie to work with, basically. And the reasons being, there are 2 time elements here. One is the date, the day it is, November 18th in this case, and the versioning here being a Unix timestamp. So Oozie triggers based on a time dependency or a data dependency. And for Oozie to actually know what the latest data is, you would have to swap the directory structure to this. So you would have to have your versioning before the actual date, so that every time we have a new data coming in, Oozie will be able to pick it up only if you have swapped our directory structure in this manner. But we were really strong on not doing it, because by doing this, we make it really hard on ourselves for debugging purposes in order to figure out what's the latest data that was processed for this day. It's not really obvious if you want to go in and find out. You got to go in through every single version that's stored in HDFS and match it with the day that we're actually looking for. And this is one of our, this is very, for real-time analytics for us that we actually want to, or for batch processing where we actually use it to. This was really important for us to actually, for purposes. So the next point is automatic reprocessing. When an Oozie job fails, it just doesn't automatically recover. So for example, we have incoming data. I'll show what our pipeline is. Our pipeline depends on downstream information. So like there's an indexing, Druid indexing MapReduce job that goes on downstream. And if the downstream job, for whatever reason, fails, Oozie will not automatically recover to reprocess data once we fix the downstream issue. It needs manual intervention to go about doing that. And this was one of the issues that we thought, okay, well, in 2020 or whatever it is, it's just not, we shouldn't involve manual intervention to actually go in and poke things around to actually do this sort of stuff. And Oozie is basically littered with XMLs, configs, and everywhere compared to Airflow, which has code where we can actually write unit tests for our DAGs, for example, to see, okay, is this configuration set up correctly? Does this job actually work? Did the DAG actually parse information properly, parse templates properly, and all that stuff? Airflow was really useful. And I don't know how much of an issue this was, but one of the really neat features of Airflow is basically helps you hand off data between multiple tasks. So as you've seen before in Sid's talk, for example, there's like a there's a DAG which too many task instances. There's a lot of task instances in there, and Airflow will let you pass data from one task instance to another task instance seamlessly. But in Oozie, it's just not straightforward. For example, if you want one job to know what the data output of the previous job actually was, you would have to dump the data somewhere in HDFS, for example, with, let's say, a success file that can act as a trigger for the second job for it to know that, oh, okay, the first job was done successfully. So now I know the data is actually there for you to pick it up. So this is one of the very neat features of Airflow. And the second one, the last one that I want to talk about very briefly is basically, so in Easy, you can actually mention what parallelism you actually want to run on. So parallelism is basically how many days do you want to look forward to, for example. So for today, if you say a parallelism of 1, for example, then tomorrow when it starts up, every day at midnight, it just goes into a waiting state, waiting for the data to actually show up. That was sort of a problematic for us because our data, because we're an analytics company, we have late arriving data, for example. So for today, we could have some fresh data for last week as well, because for whatever reason, people like have their phone on airplane mode or whatever, and then they turn it back on, the data ships into it. So what this does is basically your in Oozie, your process will go into a waiting state, waiting for data, but the data never shows up. You could have an option to either time out or that day is basically taken. So you would never move forward. If you only have a parallelism of 1, because yours is already running, you would never pick up even new data for tomorrow or the day after. These were, in summary, the 5 main issues that we actually encountered with Oozie that made us look for new solutions. And Airflow played a really nice role there in terms of offering us a solution for it. A little bit of a sidetrack on Druid. If you guys are very curious about Druid and how we do real-time analytics, Druid is an Apache project as well, and it's a really fast columnar distributed data store. And Flurry uses Druid to do aggregations real time when the query comes in. And you can get more information on druid.io. So compared to others here, our workflow is really, really small and straightforward, but each of our task instances are sort of heavy. The first one, all of these instances are custom instances that we just inherited from the existing ones that Airflow already has to suit to our needs. So, so right now we have a sensor which basically just runs, we used to have a sensor that runs every hour and every day, basically looking for new data, and then pass it on to, it gets the new data, it figures out what the new data is, then it passes on to something called druid indexer, which is another operator. The druid indexer basically kicks off a MapReduce job for it to index data into Druid. And then it also monitors the MapReduce job to figure out, okay, hey, have I successfully indexed data into Druid or not? It constantly monitors it. And once the job in the MapReduce job actually completes, it sends the result over to the MySQL updater. It's another, I guess, operator, where we just update our MySQL metatable that manages the entire state of the data that we have to say whether it succeeded or failed, so that the next sensor, for example, can actually kick off and pick up the same data if it has to. But now right now we have our own fork of Airflow where we're testing a feature called a continuous sensor, where instead of the sensor basically waking up every hour or every day, for example, we basically want the sensor to be running continuously forever. So the sensor is always running, looking for new data. Anytime a data is dropped in, the sensor picks up the data and then starts ingesting data into it right away. So that's something that we're actually testing in our own fork. So simply just looks like this. That's basically it. In terms of what we're actually doing, it's basically a sensor, Druid indexer, and a MySQL updater that we actually have going. I guess a couple more things that maybe I missed out here is because right now we're also thinking of actually using Airflow for DistCP purposes. Instead of having a cron DistCP data between multiple colos, we're thinking of actually having Airflow do the DistCP work or trigger the DistCP work from one colo to the other. That's something that we're testing right now in a different branch. And then we also have another DAG for GC purposes. Since we're using HDFS and you know the directory structure, we collect data. Our retention is like a year for analytics. And if it goes past a year, or if you know we have really old versions, for example, let's say we have like 10 different versions, but we only care about the latest version for any given day. So we have a GC DAG, which is also triggered by Airflow, which will basically clean up our HDFS directories. So we use those Airflow for two other purposes as well. So with that, that's all I have for you guys on Make an Addition. Do you have any questions?
So can you go back to your previous one? So are those, would you say the Druid and MySQL update, are they parallel or?
No, they're all sequential, for example.
Okay.
So I guess, so sensor, so it's like the HDFS new file sensor. It's a custom sensor that we actually wrote. All it does is basically monitors HDFS. The HDFS, we have our, we piggyback on the MySQL database that Airflow actually has. We have our own table, and we store the results of the sensor or the MySQL updater there. So every time the sensor runs, it checks for new data, and if there is new data that it doesn't recognize, it updates the MySQL saying, "Hey, I'm running this data on this path. HDFS path is actually running," and then it passes that information to the Druid HTTP operator, which looks at the path and says, "Okay, now I'm going to send this path over to by calling a REST API on the Druid indexing service." You pass that as parameters over there, and the Druid indexing service basically kicks off its MapReduce jobs, and it gives you back a task ID, and we basically now constantly pull the task ID, I guess every 5 minutes or every 5 seconds. I don't know, remember exactly what it is, but we keep constantly pulling that one for the result. Eventually, when the Druid HTTP operator, the MapReduce job actually completes, the next time we actually pull for it in the waiting state, it sends a result being success or failure. And we basically pass that success or failure over to the updater, which basically updates our MySQL table saying, okay, hey, for this path that you initially started running is now updated to passed or failed. Whatever the Druid actually returned. We update the meta table as well.
Okay, so basically this flow, I might have missed it, was basically to re-index in Druid files that land in S3.
Sure.
Right, okay. And not to the normal path for data coming through like Kafka. It's really for the file-based index.
Correct. This is primarily for batch. I think Airflow is primarily for batch-based. We're not using it for real time, but the reason why we're actually doing Druid is because we want to do real time for other purposes, like active devices and sessions, which go in through Storm for now, which has nothing to do with Airflow by any means, but we're using Druid for that purposes. And it's sort of become, the reason why we're moving other stuff to Druid as well is because Druid now serves as our primary middle tier, but the apps in our dashboard actually hits to query for data, and apparently it's more maintainable, a little bit more cheaper in terms of resources and maintenance-wise compared to HBase. Is basically what we thought.
I'll hand it off to you.
Yeah, I just have any questions.
I have one more. Sorry. What if you detect 1,000 files? Do you send that one Druid operator will send 1,000 HTTP requests out?
Oh no. You can. It's basically comma separated.
Okay, it'll batch it up.
Yeah.
But then that Druid operator won't return until it's completed the whole workload?
All of it, yes.
Okay.
And we are sort of fine with it. And we know that we're not going to have, so actually, let's take it back. We will have, I don't know, not 1,000 days, but because our retention is only 365 days. But we will have, at any given point when we do a backfill, for instance, let's say we're starting from last year's January 2015, and we introduce a new feature and we have new data in HBase and we want to reindex Druid, then yes, then we will, we actually sort of right now we trigger jobs that dump data in 3 month spans, for example. So when we do a backfill, for example, at any given point in time, Druid will index not more than 90 days. For now, that's manual, obviously, in order to dump data for it to recognize, but otherwise. And
you're using XCOM between them?
Oh yeah, Airflow uses XCOM between them.
Okay.
Yeah.
That is what you're
using. I'll be here if you guys have any more questions. Otherwise, I'll hand it over to Max. We're perfectly fine.
Yeah. Okay, so my name is Max. So I wrote the first commit, so I get some of the glory. Also get some of the the blame for some of the issues that might exist in the tool at this point in time. Luckily, a lot of people had jumped in over the course of this project over the past. It's been like I think a year and a half or so, and people there's been like brilliant minds joining in the project. helping out. So I wanted to take the mic for a moment to talk a little bit about what we're doing at Airbnb, what we're focusing on, and talking a little bit about, so first thing about Druid, or about, looking at how people use Airflow. It's been great to see how, this tool it does not, tell you what to do very much, just a batch execution engine, workflow engine. So people have been using it in really intricate ways. So it's really cool to see how people are using it. I want to also to thank WePay and Chris for hosting. It's great to come here, get pizza and drink, and not having to set up the meetup and all that stuff. So it's really a sign of the project growing up, where we don't really have to do these things, and it's just kind of happening on its own. There's a lot of activity on the mailing list. So I'm personally very grateful for looking at this project grow up. So it's a little bit like parenting, where it's like a balance between losing control and kind of being proud, right? And so kind of letting go, and so yeah, it's been really cool to watch. Yeah, not that much anymore. It's my teenager now, but yeah, so it's been great. Yeah, well, and it's a really cool thing to see, right? It's like part of growing up. We also use Druid heavily at Airbnb. That's why the primitives were there for Yahoo to use. Druid is a really cool piece of software. We do all of our real-time analytics using that tool. We've built other infrastructure to do data visualization on top of Druid, which is how we do all of our real-time analytics. And we also do the batch ingestion in Druid. So there's these two different paths to load data in Druid, the real-time or through Airflow, like on a batch, so we can complete our Lambda architecture. We're really grateful for Druid too. Now I'm going to talk a little bit about the stuff we're doing at Airbnb. I think one of the main thing is stability, scalability, making sure that like the main focus at this point for us, I think, is like just getting stuff to run, without too much need from us to keep it running. So I think Paul's going to talk a little bit more about the scheduler and the work that's been coming through from the community. There's been a lot of amazing work from Volke, Jeremiah. Paul has jumped in recently, and there's been so much going on there, and it's the heart of Airflow. So I think it's good to take the time to see where we're at, what's coming up, what are some of the guarantees around the scheduler. I'll talk about the other things before you jump in, Paul. So one thing is containment. I've already talked about this. So we care a lot about containment because we suffered from the fact that Airflow is not contained on workers pretty heavily, and we want to deprecate a system that uses containment. So Docker, C groups, impersonation, so some security construct. I think we're also evolving internally in terms of like Kerberos, so we'll get involved into that eventually. I think that's next step, but containment first. One thing is versioning. So we embrace configuration as code, right? That's like one of the premise of Airflow. That's what makes it super powerful. And we want to keep going that direction. We look at pickling. If you use, or if you've seen some pickle references in the code, I think we're going to fully deprecate that eventually. And we want to like go away from any type of serialization, or at least like that's a proposal we want to submit to the community. So you guys will be involved. But we want to fully embrace configuration as code, and that means mostly moving Git repos around if we need to do versioning. So versioning is important. So when the scheduler says, please run this task to a worker, there should be a stem that says run this version of this task, and we should know what version it was that was run on the worker. So the way we want to implement that is by having some sort of like Git time machine that will allow a worker to kind of get shallow clones, so get the Git repository as of a specific version, and then run the code in the repo as of that version. So that's the proposal we want to send. Of course, like we want to be backward compatible, so that's something you're going to turn on if you want it, and then there's going to be a service to kind of for the worker to fetch a specific version of code. If you don't want to turn that on, you can still maintain your, we use Chef right now to synchronize all the Git repos on different workers. Other people use different means to do that. Like cron apparently works as well. So So like all these features, I think will be optional moving forward, at least until 2.0, where we might deprecate some stuff. A side track here is we don't really know what other people want out of this project. I mean, we know that they want stability, scalability. I think we want to run a survey probably within a month or two to get a sense for what the community wants. People can want different things, but it's good to know overall as a community, what do we want? What's important for us as a community? Then we can match people together so they can work together on things. So this open mic here, later on, if you want to say, my company or I personally want to get involved into working on feature X, you can find other people that care about these features and get together eventually and collaborate on these features. Get your Apache committer wings, you know, so get badge for that in the process if you want to. There's a few other things we're working on. The scheduler, we'll get back to it, but in terms of vision, we care mostly about scalability, easy maintenance, auto deploy, like just to make this tool as stable as possible. Internally, we have a staging cluster. I think we're one of the only places where we have a good staging cluster. We deploy the new versions in productions. That means any problematic commit that one of you might have written or merged will hit us first. We are, like Airbnb is, everybody else's staging environment at this point, and we want to protect ourselves because we've been hit, you know, in the past. We're also thinking about project management, and here we're not sure exactly how to manage a community. We know how to manage each other more or less, but eventually I think we want to define some processes and be more upfront about the work we're doing and set the tone for if you want to do ambitious things in Airflow, like kind of have a process for that. So that means things like having a design document, having some sort of formal approval, you know, having PRs, collaborating with people, asking for feedback. I think that the way we've been doing things has been good, but like personally, like even at Airbnb, we've not always been the best as to like making it clear what we're going to work on next, involving people, submitting design documents. So we want to get better at that. And I think for some of us, it's the first big large project we're part of. Others in this room have worked as part of other Apache projects, but we're learning as we do this together. So we're relying on other people. So I think I'm probably forgetting like things that are really important to us, but like impersonation, security, containment, versioning. So those are things that I should have thought about early on, right? Like when I thought pickling was going to work great. Pickling and serialization, I think, is problematic in Python. So we're stepping away from that, and we're tackling that at this point. And then I'll let Paul talk about the scheduler, kind of do a recap maybe of what's been happening and where we're going with the scheduler.
All right, so I'm Paul. I'm one of the people working on Airflow at Airbnb. And so to give you a recap, oh, and also Dan too over there. But yeah, to give a recap of what's going on, internally we have a scheduling system in place called Kronos, and we're trying to use Airflow to deprecate that. And so as Max mentioned previously, our goals is scalability and reliability. Basically, if anyone has to wake up in the middle of the night to fix Airflow, that's not a great situation. And so some of the work that we're doing on the scheduler side is to make sure that Airflow runs and is very stable. Also on the open source side, Bulk has been doing a lot of work on doing a lot of refactoring, making the code a lot cleaner, and also logic around DAG runs and fixing race conditions. There's some flux going on with how states are managed in the Airflow scheduler, and so probably in the next release, there'll probably be some changes there. At Airbnb, the problem we've seen with the scheduler is that I think Chris had a pretty nice setup where when people check in DAGs, tests run, and people have some confidence when they click the merge button that everything will run okay. Unfortunately, at Airbnb, we do not. People can merge pretty much whatever into our DAG folder, and this has been this few times. One of the main problems we have in the scheduler right now is that all these DAGs are parsed within the same process as the actual scheduler itself, and also like all these DAGs need to be processed in sequence. Like all DAGs must be processed once before the scheduler runs into the loop again. And so in our production environment, this loop is like pretty long. It's like 6 or 7 minutes. And if someone checks in a bad DAG, like imagine if someone does like sys.exit in their DAG code, the whole schedule will exit too. And so we've been doing some work to process DAGs and sub-process so that this doesn't happen. And in general, the scheduler work we're trying to do is for reliability. And we want to have as few surprises as possible. And so as part of the process in deprecating our old system, we want like very, very high uptime and want to make sure that no one needs to wake up in the middle of the night to fix some issue. But yeah, it's sort of a brief overview of what's going on. And I guess it's like open mic, how should we handle this? Oh, okay. Okay.
So before we do that, I just wanted to get, do we have two? No, this is more interesting.
Okay.
Right. Don't take away this square spot. No. So one question I have is, how many of you are on the dev list? Raise your hand. That is not a good sign. All right. Everyone here needs to be on the dev list. So we mentioned things like taking a survey. We're going to follow some Apache processes for that. And the dev list is the way we're probably going to start it. Are any of you on the commit list? Okay. How many of you are on the Jira? All right. So maybe we take everyone's car keys away and they don't get to leave until they're on these. Oh, wonderful. Okay. Well, that was what I wanted to get a hold of. Chris?
I have a question about the dev list. So it says that there's an archive of it and some UI. I will just say that as somebody who gets thousands of messages a day because new DAGs come in and I get lots of emails from them for a while till I trust them, and then I tone that down. Things like trying to track an email list or even the digest at the end of the day, really, really, really problematic. Like my inbox is now the worst possible place to get me in general. Airflow's new here. I don't know.
So you're looking for a web UI?
Or something.
Yeah, so let me just all right, I'll do it too. We're all doing it. There's a few. I mean, I can even show you. There's actually a few websites where you can go. The Apache one is very clunky, but it's the canonical truth. There's also several other websites that do indexing of all public Apache mailing lists. So you should be able to find the Airflow dev and commits list on there. I mean, I can literally, if you do that, Airflow. We're gonna onboard everybody. It's gonna happen. Here you go. This is it, right? So I can go to June. I can see, like, if I go to page 2, I can literally see, I believe, the Airflow meetup I just sent. Right? So it's there. Like I said, it's a little clunky. There's some better ones out there, but this should at least get you going. Yeah. Well, I got an idea. So one of the things we're talking about with containerization is we're going back and forth on Mesos. Kubernetes, vanilla Docker, like how many people here are running Kubernetes? Okay, what about Mesos? All right, that's pretty definitive. At least within the Bay Area, Redwood City area. Okay, and what about anything else that I'm not aware of? Swarm, oh God. Okay, is Kubernetes with Docker or with Airflow integration something that would be interesting to people? Yeah, 1, 2, 3. Okay, you're playing with it. Cool, because we're like heavy Kubernetes right now, and I think it would be awesome for us to be able to run Airflow DAGs within Kubernetes because all of our microservices.
Would you be replacing Celery with that, or is Celery going to kick those off?
I think like from the get-go, we wanted to write interfaces and then implement these interfaces. So the Celery stuff is there to stay, I think. And, you know, we don't want to be a premise for people to have to install something gigantic to run Airflow. So something you grow into the same way that you grow into your data infrastructure, or your data infrastructure grows over time. Yeah, so I think that we're thinking about like a Celery, like a contained Celery might exist at some point. Local executor will be there and will be sustained. And there might be like restrictions as to like some features are not available depending on the executor that you use. For now, it's still maintainable. I think there's a point beyond which the common interface for a lot of implementation becomes a mess. But that's an open discussion.
Raise your hand if you're using Celery Executor. Okay, but 5, right? 6 people. Now 3 of you are from the same company, right? Airbnb. All right, raise your hand if you're using the local executor. Okay, the other people want to get into Airflow, it looks like. So you guys are not, yeah, the people who didn't raise their hands, are you guys newbies to Airflow? Because you have to be running one of these 2 executors, or sequential. Sequential, okay. So it's an even break, but I think we were looking for maybe a solution that is generic, scale out solution. Okay. With pickling turned off.
Celery isn't much, right? Celery is just like a library with function decorators, and it knows how to talk to 2 message queues. So, and it can run a worker with a certain number of slots. It doesn't do any containment, but it's fairly lightweight. So if, arguably the local executor runs in a sub process within the executor within the main process. So you run a scheduler, the local executor, it runs in a sub process. That's a little bit janky. It's a little sketchy. You probably want to take it out and then do I have 2 different processes that have cross-process communication. And there you go. You have Celery, like more or less. So that's been the question there of like whether we want to refactor if we want to refactor the local executor out of the main process, then we have something that's essentially very close to Celery. It seems like pretty lightweight, but you look, there's like over 1,000 commit in the Celery repo. So somehow something about this problem is going to be challenging, which I think more mature companies, will want to use something like Kubernetes for that and other things. We looked into Yarn, so Paul has more detail into that. But we look at Yarn, and there was no way that we're going to install all the stuff that's on the Airflow workers on the Yarn, on the data nodes, basically. So then we look into containment inside of Yarn, and there was kind of a no-go. It didn't seem mature. That was about, 4 months ago?
We looked into running Docker containers on Yarn, and on the surface it looked great because it seemed to fit our needs perfectly. And if we had some sort of Yarn executor, it would really fit in well with our Hadoop ecosystem. But one sort of deal breaker was that it doesn't support Hadoop in secure mode, and security is getting pretty important at Airbnb. And so if we're going to move to a secure Hadoop cluster, then this would be out of the picture. And so we're sort of in a state now where it would have been great to have Yarn and Docker containers, but it doesn't seem to be very well supported right now. And so unless someone finds us to the contrary, which would be great, but that's sort of the situation.
No, but that's the great thing of being a community. People are running all sorts of experiments. Like we see already, we run Airflow in very different environments. The unit tests haven't been as great as they should be, and in some cases, the community has been effectively unit tests, right? And we all take that's not the way it should be, but we all grew up together. So we're still looking at solutions there. The main point is we should write interfaces and let different companies leverage the infrastructure that they have as much as possible. So we try to do that. I've been trying to do that from the first line of code to write an interface and then implement it, even if it's just one implementation. So it's not bound to our infrastructure and tightly coupled. The first thing you know, it only works for you, or you can't open source. If you have an open source from the get-go, it's either it's useless for most people, or you can't open source anymore because it's too tightly coupled with your stack. So we kind of committed with this approach, I think.
One byproduct of using Celery, and we use Redis for the queue, is that all of a sudden I've got a Redis cache that's actually in every task. So one thing we do is crawl every server we have. And our servers are used for a lot of different, some are multi, some aren't single tenant, but I don't actually want to hit every server, do that crawl 40,000 times. actually rather do it 4,000 times, which means I need a cache. And I thought that was going to be a hard problem. Because I was on Celery, it was literally like a 20 seconds extra. It's like, oh, wait, it's already, everything is already there. So as we move towards the idea of containerization, so supporting both the lack of containerization, or, you know, supporting the ability to have communication and caching is also really an interesting challenge, I think. Being able to run multiple executors, so run Celery for one subset through one UI. Like right now, the UI, it seems like everybody has to run it. You run a UI for dev, test, and stage. It would be really nice to be able to have a shared UI where you can see and even progress things, but that's maybe longer term.
One thing we haven't talked about in the list of things that Airbnb wants to work on, or that are somewhat in our top list of priority, is to make the web server stateless. So internally, there's a lot of movement. Our DAGs are slowly changing, but there's a lot of new DAGs and iterations on DAG. One of the most common question we have on the Slack channel is, I've updated my code, why is it not reflected in the UI? There's a bunch of like intricate challenges there. So the web servers are stateful now, and they do parse the DAG bag. So every web server worker as a copy of the DAG bag that it's trying to keep in sync with your Git repo. The reality there is that there are some challenges. I could get into a lot of details what these challenges are, but the main thing is like getting the web server stateless so it reflects the Git repo at any point in time. We're not quite sure whether we're going to do allowing to visualize your DAG as any SHA of the Git repo. So it's being able to navigate like the time machine of the different versions. Show me my DAG as of you know, this SHA in the Git repo. But for sure, we want a stateless web server that can show you the current state of your DAGs, and potentially like the version, the history of your DAGs over time. So with Pickle, it was supported originally, right? But the truth is there's a lot of problems with serialization. Main ones being you deal with like Python 2, Python 3, different version of your object. Stuff might not be serialized over time. And we definitely want to go away from this idea of like serializing JSON to XML to pickles. Everyone that we spoke to were like, don't do that. There was some conversations about artifacts, right? So creating pecs. We looked into that. That turns out it's also a shit show. A different smell of, but like also like in the same realm. So that's kind of where we're at. So we want to embrace like configuration as code, parsing the DAG at runtime, and somehow figuring out how to run a stateless web server.
So I think at this point we'll just do open mic. So I'll hold this. Anyone who wants to come and talk, and then we'll just break out into people can just sort of chat like informally. Last time we did this really cool thing of a breakout session. It took like 25 minutes to actually create the groups, and that's probably we'll do something organic. People can just like mingle and talk about what they want to talk about. So who would like to come up here and grab, or I'll throw this at you. All right.
As you probably saw from the sad slide I had on DAG deployment, I'm pretty bummed about our current cron-based manual restart. So I'm definitely interested in hearing any feedback anyone has about how they deploy DAGs. I think that would be super useful.
We just use a continuous integration on Git. So we pull, actually we just pull master. It's on the list of things to move that and do a branch. But we run on top of EFS, so both the logs and the DAGs sit on an AWS EFS partition. It leaves behind a bunch of weird files, which periodically when EFS, it's NFS, but it's Amazon's NFS as a service. Yeah. But it's a beta. Well, I think it is. Oh, all right. Well, sorry. So we use NFS. It's really easy to configure, but it makes it really simple to share. And it also means I never, ever worry about running out of log space. Like we've been running, I don't know, we've got hundreds of thousands of DAGs have run. Some of them are really long log files. We're at 1%. It goes forever, essentially. Infinite scalability. Without the challenges of setting up things like S3 It's nice to have it both as a file system and as, you know, so you can mount those and go through them and look at them.
Getting back to that sort of state discussion, do you bounce the web server and scheduler when new DAGs get committed, or how does that process go? Do they just show up in the folder and then at some point it gets bounced and they start going?
Scheduler seems to be picking them up. Maybe that's because we're running Celery. I don't know. Yeah, the scheduler seems to have a loop. What I'll say, and so does the web server. However, it regularly, the scheduler seems to always get the latest version. The web server does not, but we're pretty confident now. I mean, I think we've moved wholeheartedly into Airflow really quickly. But that has not been a real challenge for us. More of a challenge so we have we have Apache Airflow utils.py, and when we update that seems to be a problem. That there are no DAGs in there. I sort of started with SIDS and modified that. That is a challenge. For us, I can see long-term it will be at some point really important to be able to click on the DAG run and see it associated with the version that ran then. Yeah, it's okay when it's just me and a couple of people, and like you guys, we know a bunch of things we should be doing and we're not yet, and all of a sudden we're in production, but because it works, right? And because cron sucked so bad. We actually use cron to kick off. We use external scheduling for 100% because when we started, we were using local executor and had some challenges, and just cron actually turns out to be incredibly good at kicking off. I mean, it's good at saying it's 5 after run. It's impossible to track what was happening. We plan to move to the scheduler again at some point, but see no reason to do that with its zero pain point for us. So, and I don't know if that maybe affects the way it picks up the latest version.
So I think what we'll do now is, I don't want to keep everyone captive in their seats. Just everyone just mingle. Sounds good. Nobody had any announcements to make about jobs or WePay? No jobs at WePay?
Yeah, I mean, obviously, like I said in our slide, we're definitely hiring. I'm sure if anyone else wants to announce they're hiring, that would be great too. Yeah, Airbnb, Apogee are hiring. Okay. Anybody else? Uber's hiring. Okay.
We're not hiring.
Okay. You're unwelcome at Agari, guys. Oh, okay. He's joking. Yeah, so I think, like Sid said, I think we've hit like what 2 hours on the meetup. So I think there's a lot of informal discussions that are probably worth having, but I don't want to keep it too structured. So have at it. Thanks for coming. Yeah.
Oh, really?